Scientists have found that a thick layer of diamonds may exist hundreds of miles beneath Mercury's surface.
Could Mercury contain diamonds? The most recent image obtained by the James Webb telescope has completely altered our preconceived notions. It demonstrated to us that even an unassuming planet like Mercury may be hiding a wealth of information, much like diamonds could be found in its craters. This incredible discovery, made directly under the sun, showed us that our equipment was perfect. What startling mysteries may Mercury be concealing? Let's explore these pressing mysteries in more detail. An incredible deep space discovery. The initial image that we obtained from Mercury's orbit was breathtaking. It was exactly what we had hoped to see as soon as it popped up on the screen. We realized then that we had really succeeded and that everything was operating as it should have. Just now, NASA made public an amazing finding from deep space that was located on the little planet. Despite its unassuming exterior and near proximity to the sun, it conceals some intriguing and maybe lucrative mysteries below, such as diamond-containing craters. But when we zoomed in, the room became quiet. There, in the shadow of a crater, stood an obviously man-made building, a secret that Mercury was never intended to harbor. This little planet, which formerly appeared like just a feint through our telescopes, has become a source of astonishment. With the help of cutting-edge equipment from the James Webb telescope and other missions, we've started to unearth some incredible discoveries. Recent research implies there might be diamonds deep within the searing environment. That's not all, though. Because of the very huge and peculiar core, scientists are having to reconsider their theories about the composition of planets. For many years, the landscape's secrets remained mostly unknown, but modern technologies have begun to reveal them. A significant step toward planet exploration was taken by NASA with the Mariner 10 mission in 1973 and the Messenger mission in 2004. Messenger captured detailed images of a surface replete with craters and odd ridges that resembled our moon while it was in orbit. These photos revealed a crater-filled, dense planet with an unexpectedly strong magnetic field and a bigger core than previously thought, which caused scientists to reevaluate their theories about the planet. A considerably sharper image of the planet was provided by the Messenger probe, which was meant to circle 31 years after the Mariner 10 mission. It remained in orbit, collecting an enormous amount of data and taking more than 200,000 pictures, revealing previously unseen areas. The highest concentrations of calcium and magnesium on the darker side were among the most intriguing discoveries. Scientists are still unsure of how these elements got there in light of this revelation. Although the circulation of liquid iron in the Earth's core produces magnetic fields, the distinct interior structure produces distinct magnetic characteristics. While nighttime lows might approach -300 degrees Fahrenheit, daytime highs can reach 800 degrees Fahrenheit, hot enough to melt lead. This large temperature change happens because the thin atmosphere cannot hold onto heat. Recent research has revealed several unexpected surface traits, even in spite of these harsh circumstances. In 2012, data from the Messenger mission showed volcanic activity, including hints of explosive eruptions, defying the conventional notion that the planet was geologically dead. Researchers declared that they had discovered water ice in a few of the Arctic craters. Despite the planet's close proximity to the sun, the ice remains frozen due to the extreme coldness of these craters. Even more intriguing questions are brought up by this discovery, such as the possibility of simple life existing on the planet despite its hostile environment. Could there be life there? Although it may seem improbable, many types of life on Earth are able to endure the harshest environments conceivable. Therefore, even in its coldest and iciest places, it's not completely out of the question that anything may reside there. The European Space Agency and the Japan Aerospace Exploration Agency launched the Bepi-Colombo mission in 2018, and it is currently traveling toward the planet. With the arrival of this spacecraft in 25 years, we will be able to examine the surface, composition, and geological past in greater detail. However, the planet continues to astound scientists. You wouldn't anticipate a planet this near to the sun to have features like a strong magnetic field and even signs of aqueous ice. The way time is handled there is even more bizarre. Unlike Earth, where we have clear days and years, the spin and orbit form a highly unique pattern. Did you know, for example, that a year is shorter than a day? Let's investigate what makes this planet so fascinating, its distinct day and year. Planets typically circle the Sun once a year and rotate on their axis once every day. Their secrets are revealed. But it defies these accepted guidelines. The year of an Earth is very short. It takes only 88 Earth days to complete one orbit around the Sun. One complete revolution takes 176 Earth days at the same time. That means that a day is twice as long as a year. If you were standing on the surface, these odd events would result from this strange time pattern. Imagine witnessing the sun rise, grow larger in the sky, pause, retrace its steps, and then resume its course. This occurs as a result of the slow spin's inability to keep up with the sun's rapid orbit. However, this is not the only peculiar aspect of it. The sluggish spin is supposed to be caused by tidal locking. This is a gravitational impact from the sun that has slowed down the rotation over billions of years. It rotates 3 times for every 2 orbits around the sun, in contrast to our moon, which is perfectly locked in sync with Earth's rotation. This phenomenon is known as a 3-to-2 spin-orbit resonance. That doesn't mean the odd conduct stops either. The planet is subject to harsh circumstances due to its distinct day-night cycle. For an extended period, one side is exposed to the sun and becomes quite hot, while the other side remains in the dark and remains frigid for an equal amount of time. It also has an extremely thin atmosphere, known as the exosphere, which is continually lost to space and then regenerated by radioactive decay, the solar wind, and small impacts from meteors. That's not the worst of it, though. In 2020, scientists were astonished to find much more water vapor in the exosphere than they had predicted. This water vapor is most likely the result of interactions between oxygen in the stony surface and hydrogen from the solar wind. The long days and short years also have an unexpected influence on the magnetic field. It's a small planet with a sluggish spin, yet surprisingly, scientists discovered that it has a magnetic field. According to recent research, the unusual orbit and rotation may be influencing a unique process known as the dynamo effect within the liquid metal core, which produces this magnetic field. This reduced magnetic field is nonetheless vital because it helps shelter the planet from the solar wind, which would otherwise take away its thin atmosphere much quicker. Still, Mercury's quick orbit and sluggish spin generate some genuinely unusual circumstances on the surface. For instance, the hottest areas on Earth are found in regions known as hot poles, where the sun appears to freeze in place in the sky. In the freezing, dark zones near the planet's poles, where sunlight never reaches, scientists have detected water ice. It's odd to discover ice on a planet so near to the sun, yet it exists due to the peculiar spin. Some craters near the poles are always in the shadow, making them exceedingly frigid. With the sweltering heat in other regions of the Earth, these ice craters stand in sharp contrast. Scientists are curious about whether other materials, such as organic compounds, might be concealed in these icy regions after discovering ice. But researching the planet is no simple undertaking because it circles the sun so swiftly. Major obstacles for space missions arise from this quick orbit and extremely lengthy days. 2018 saw the launch of the Bepi-Colombo mission, which is presently traveling toward the planet. It modifies its course by harnessing the gravity of Venus and Mercury. After 9 flybys, it is predicted to arrive in 25 minutes. However, the severe day-night cycle of the planet must be addressed by the expedition. When the spaceship is in the sun, it will experience extreme heat, therefore it must save energy for the long, chilly nights. These extremes demonstrate how difficult it is to investigate a planet like Mercury and test the boundaries of current technology. Next, we find out why this planet rotates so slowly and what it tells us about its past. Getting ready for the hidden threat research into the planet's sluggish rotation has recently been conducted. It appears that it was slowed down by the gravity of the sun and impacts with massive objects like asteroids, although it may have originally spun far more quickly. This helps us comprehend how planets in our solar system evolve over time and provides scientists with fresh information about the planet's past. The massive iron core of the planet, which makes up over 85% of its volume, is another thing that fascinates scientists. Compared to the Earth's core, which makes up only 15% of the planet, this is far bigger. Certain researchers believe it was previously a much larger planet, including Dr. Eric Asfog from the University of Arizona and Dr. Nancy Chabot from the Johns Hopkins Applied Physics Laboratory. They think that following a significant collision early in the solar system's existence, it lost the majority of its outer layers. However, this was hardly the most shocking discovery. Even though it's a tiny planet with a moderate spin, the planet nevertheless possesses a magnetic field. NASA's Messenger mission made the startling discovery that its magnetic field is only 1% as strong as Earth's. This discovery calls into question our understanding of magnetic fields on smaller planets. The University of British Columbia's Dr. Katherine Johnson, a planetary scientist, and her colleagues are now investigating this to find out more about the planet's peculiarities. These findings are causing scientists to reconsider their hypotheses regarding the formation and evolution of planets. The planet's discoveries continue to challenge our preconceived notions about our solar system. The magnetic field of the planet is a little strange. It is displaced by around 1/5 of the planet's radius rather than being centered. This anomalous location might be caused by uneven crustal thickness, which could alter the planet's internal heat flow. Scientists discovered elements like sodium, potassium, and sulfur on the surface in 2021. Finding these elements on a planet this near to the Sun was unexpected, since normally these elements would vanish rapidly under extreme heat. According to Dr. Patrick Peplowski, these components might have been brought about by asteroids or comets striking the planet after it formed. Another startling observation was water ice in craters near the planet's poles. These areas are sufficiently cool and shaded to prevent ice from melting. Nancy Chabot, MD, was instrumental in this finding. Carbon-based molecules known as organic compounds are also found in the same craters. These might be the same ones that brought life to Earth. This suggests that the planet may have some information on the origins of life in our solar system. That's not all, though. Scientists thought the planet was geologically extinct for a very long period. Nonetheless, indications of recent volcanic activity were found by the Messenger mission. They discovered patches of what appeared to be volcanic vents. This indicates that life is still occurring on the planet. The planet's south pole is another enigma. Its topography is untamed and chaotic, including peaks and valleys the size of Texas. Dr. Thomas Waters thinks that severe quakes, induced by changes in the planet's orbit due of the Sun's pull, may have generated this unique topography. Dr. Amir Khan discovered that the planet has a larger solid inner core than Earth and a liquid outer core after analyzing data from the Messenger mission. The peculiar magnetic field might be explained by this unusual structure. There is still much to learn about our solar system, as these findings refute what we previously believed to be true about the formation and evolution of planets. Now, we descend into the planet's core and surface to uncover what surprises they disclose. Secrets under Mercury's surface. The planet's width, which makes up almost half of its core size, is approximately 1,265 miles. Compared to Earth's inner core, which makes up only 20% of the planet's overall core, this is a far bigger amount. It's little, yet its magnetic field is rather strong. Though weaker than Earth's, it is nevertheless quite important. The planet's mantle is far thinner than previously believed under its rocky surface. The mantle of the Earth is just approximately 260 miles deep, according to recent study. This is incredibly thin compared to Earth's mantle, which is roughly 1,800 miles, or 2,900 kilometers, thick. The planet's geological activity and the distribution of heat inside it are both impacted by this thinner mantle. An important discovery regarding the planet's surface was made back in 2012. The shallow depressions known as hollows are proof of historical volcanic activity discovered by the Messenger spacecraft. These were created when some substances escaped into space and evaporated, indicating that the planet may contain more volatile elements than previously thought. However, this wasn't the most unexpected discovery. After examining further MESSENGER mission data in 2020, researchers found a massive, prehistoric magma reservoir buried under Mercury's crust. This massive lava lake most likely had a significant impact on the formation of the planet's interior structure and surface. Additionally, it could provide an explanation for some of the peculiar surface features, such as the vast, level regions referred to as the northern volcanic plains, which were probably formed early in the planet's history by enormous lava flows. In 2022, a startling discovery was made. Signs of trapped nitrogen below the surface were discovered by the researchers. It is possible that this nitrogen represents remnants of a former atmosphere driven underground by intense heat and solar radiation. This finding begs intriguing concerns regarding possible historical climatic conditions and if the region was ever more habitable. However, the tale is not over yet. Ice that most likely originated from comets or asteroids striking the planet in recent millennia can be found in some of the craters that are shaded from the sun. It's possible that dark objects, maybe organic substances, also came through these holes. These materials offer a rare chance to gain additional insight into the distribution of organic compounds across our solar system. The surface displays several significant distinctions from Earth, including as the lack of plate tectonics, and tells a tale of its lengthy and complicated past. It is contracting as it cools, even in the absence of plate tectonics, leading to many surface fractures and faults. These distinctive qualities contribute to our growing understanding of this intriguing and multifaceted world. Significant fissures reveal the underlying strata when one landmass pushes against another, providing further information about the region's geological history. In 2019, scientists discovered an unexpected discovery: it could still be evolving. Beside the bigger fissures, they discovered grabens, which are tiny, narrow valleys. Grabens are formed as the Earth extends, and the fact that they have just recently appeared indicates that the surface is still changing. Its distinct magnetic field from Earth's is another peculiarity. Its magnetic field might originate from a different source, such as a layer of liquid metal around a solid core that functions like a dynamo, whereas the magnetic field of Earth is produced by the flow of molten iron in its outer core. Additionally, there has been discussion on fissures and openings below the crust that may let the passage of heat and potentially even liquids. Despite the seemingly dead top, some scientists believe that there may be pockets of water far below that are kept from freezing by the residual heat. Considering comparable circumstances on other hostile celestial worlds, such as Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, both of which contain seas beneath their ice surfaces, this theory isn't as crazy as it seems. Therefore, it is not impossible that there could be water beneath the parched surface. An investigation of the core, learning more about these obscure regions, piques our interest and helps us comprehend the continuous mechanisms that shape it. Something else to think about is that this information may also help us understand the geological processes occurring on other planets and moons. Subsequently, it turns into an essential component of the wider picture, enabling us to investigate and gain further insight into the solar system and its historical evolution. But remember, the narrative doesn't finish here. It never ceases to amaze us, and the more we discover, the closer we are to unraveling the secrets of our cosmos. What internal changes have occurred over time? What unusual substances may be present under its surface, and what might these disclose about the origins of our solar system and the formation of planets? These are important topics that highlight the need for more research. Every new discovery we make about the planet's interior helps us comprehend not only this one, but also how all the planets in our solar system form and evolve throughout time. Scientists are eager to see what discoveries may be made on upcoming space missions. Despite being tiny and near the sun, it still has a lot of mysteries to solve. We may learn more about what's within from these secrets. We may discover a great deal about other planets in our solar system and perhaps beyond by looking into these aspects. It could help us understand how planets survive in severe environments around their stars and how they stay stable for billions of years. Every new piece of information that scientists gather and send out via probes has the potential to alter our understanding of space. It is an exceptional location to test our theories about how planets form and evolve because of its intense heat and proximity to the Sun. We get more questions as we learn more, which piques our interest and motivates us to investigate it and other planets even more. Despite being one of our nearest space neighbors, there is still a great deal we don't know about it. Regarding its surface, core, and internal processes, we still don't know everything. Researchers believe that by delving further into it, we may uncover secrets about not just its past, but also the origins of other planets, such as Earth. Every new finding may provide insight into the formation and evolution of planets in our solar system as well as in other star systems. It is the ideal location to test our hypotheses about how planets develop and survive because of its severe environment, which includes intense heat, cold, and a thin atmosphere. Researchers are interested in learning how a planet this tiny can survive for billions of years in such close proximity to the Sun without perishing. Does it have any unique elements that enable it to withstand these circumstances? Might these substances also exist on planets in other solar systems? Every new expedition there has the potential to alter our perception of the cosmos. We can discover more about its surface, atmosphere, and interior workings with the aid of satellites and probes. Our capacity to investigate technology advances when new tools and technologies are created. Every new mission has the potential to advance our understanding of the cosmos and help us unravel the secrets of this extraordinary planet. Might Mercury provide the means to find extraterrestrial life? For more, please like, comment, and subscribe.